so the first example was one we could solve using geometry. The second example is one I can't solve using geometry because it's a parabola shape, so it's got a curve to it. So I can't set it up with a nice geometric curve where I can find area of a triangle, area of a rectangle. So this one I actually have to do, and again, the book right now only does left hand, but I'm going to do both left and right because, again, I'm kind of combining 4.2 with 4.7 where they do both of them. They do it in that order for some reason. So I'm going to do both of them here, even though right now you only really need to know left-hand sum for your MyLab stuff. Alright, so I've got my function, x squared plus 38x minus 50. I want to find the approximate area of the region of the curve. I want to use 4 subintervals. Which means I'm going to divide it up into 4 rectangles. Alright, and I'm going to draw the picture. Just again, I think it's a good rule of thumb to have the picture. And so, I remember I'm starting at 10, stopping at 30. And so that's where I'm going to just use my calculator to make sure I've got a good picture. I'm going to type it in my calculator, make sure my window's big enough, 0 to 30. And so 10, when I type 10 in, it comes out 230. So I'm just going to mark off 10, 230. So this would be at 10, 230. And when I type 30 in, it comes out 190. Oh, I should make 10 go a little higher. So at 30, it's at 190. And it is the parabola, so it's a parabola going up and coming down between those 2 points. Alright, and so this is the area I want to find. I want to find the area between 30 and 10 of this particular function. And I want to find this area. Alright, and again, I'm going to use both rectangles from the left and the right. And so first thing, I'm going to divide it up into 4 subintervals. Alright, my change in x is, remember, b minus a over n, where n represents the number of intervals I want. B are my endpoints, 30 and 10 is a, so it's 30 minus 10 over 4. And so my change in x, which is my width, comes out 20 over 4, which is 5. Alright, so each of my rectangles will have a width of 5 units. And so what we do is, we break this down into 4 intervals, right? I'm going to make this into 4 intervals. So my first interval is going to start at 10. It's going to go over by 5, so I'm going to go over to 15. Then the next interval starts where that one stops. So 15 over 5 puts me at 20. Then 20 over 5 puts me at 25. And then 25 over to 30. And so neatly, but that would be at 15, 20, 25, 30. And so there's where my division are, right? I'm 5 units apart for each of those. And so now I'm going to find the left and right hand area. So again, I'll start with the right, because I just prefer to start with the right, what's called the right hand sum, in order to approximate my area. Alright, so the area is the change in x times f of x for all of my rectangles. Right? Change in x is 5, and then I find the height using my right endpoint. So my right endpoints would be 15, 20, 25, and 30. So if I draw that, I'm starting here at 30, I hit my curve, I go over, there's my first rectangle. So that would be that one on my right side, go over, my next one, go over. And there would be my 4 rectangles, right? There would be area 1, area 2, area 3, area 4, right? Area 1 plus area 2 plus area 3 plus area 4, which I find those areas by taking the change in x times the function value using the correct endpoint, right? F of x uses an endpoint. Alright, so for this particular right-hand sum, my area is 5. Alright, that's the delta x times f of, well, my area on my first one is at 15, right? F of 15. 5 times f of 20, 5 times f of 25, and 5 times f of 30, right? So there is my area 1, area 2, area 3, area 4. And now I find them. Remember, I'm finding the f values by plugging my endpoints into that original function. Negative x squared, 38x minus 50. You can just use, if you got the picture on the calculator, just use the value key on the calculator. Now, before I get started, I'm going to factor out the 5, so I only have to multiply by 5 once. So I'm going to pull the 5 out, and I'm just going to find my function values and add them up. Alright, so f of 15, when I plug f of 15 in, I get 295. That's the height of the first rectangle. F of 20, when I plug f of 20 in, I get 310. When I plug f of 25 in, I get 275. And when I plug f of 30 in, I get 190. Those are each of my heights. And I'm going to multiply them by 5 after I add them up. So I'm going to add them up. So it comes out to 1,070. So those are times 5. And so the right-hand area is approximately 5,350. That would be the right-hand sum. Alright. The area would be somewhere close to that. Now the left-hand sum. Alright, now the left. So again, I find my areas by taking delta x times f of x, but this time f of x is using the left endpoints. So if I look at I'm going to write down my intervals again. This time I'm using the left one. So the left one would be, I'm using 10, 15, 20, 25. Those would be the left endpoints when I find them. To get my area 1, area 2, area 3, area 4. And maybe I'll do a different color. Green. So I'm going to go back up to the picture. I'm going to draw them on the same pictures. I don't feel like redrawing the whole thing. But using my left endpoints, I'm going to use a green color. So I'd start here at 10. My first rectangle would be there. My second rectangle would actually be close to that one. My third rectangle would be, if I go up and hit it, would be bigger than that. There we go. My fourth rectangle would be there. Alright, now I do draw them out individually if you look at my guided notes filled in. But this would be the first rectangle, this would be the second, this would be the third, this would be the fourth. Alright, using the left-hand sum. Alright, so again, using the 10, 15, 20, 25 as my heights. Alright, so from the left side, it's still 5 as my width, that's my delta x, and then f of x using the left endpoint. So it's going to be 5 times f of 10, that's area 1. 5 times f of 15, that would be area 2. 5 times f of 20, that would be area 3. And then 5 times f of 25, that would be area 4. And again, we stop there. For some reason, students also want to then do the 30. Don't do the 30, right? We stop at 25, the left of that. Alright, so 30 is not included. You'll notice that 3 of the values are repeated. Basically, we interchange left and right-hand sides. Right? I get the same 3 values up here. 5 times f of 15, 5 times f of 20, 5 times f of 25. But what I'm doing is, well, I replace the 5 times f of 30 with 5 times f of 10. Right? This way, so you're interchanging the left. That's why we interchange left and right-hand side. Alright, now I'm going to write it out. So it's just like before, I'm going to pull my 5 out. I find f of 10, f of 15, f of 20, f of 25. Alright, so f of 10 is 230. F of 15, which I found before, was 295. F of 20 was 310. And f of 25 was 275. Alright, add those up and multiply by 5. So those add up to be 1,110, which comes out to be 5550. Alright, and so that would be the left sum, which again is what the book covers in 4.2. It does the right sum in 4.7. So again, I'm kind of combining 4.2 and 4.7 here. Right, so the area would be somewhere between these two values. Right, it'd be bigger than this, smaller than that. So it'd be somewhere, again, a lot of times what we do is we average the two. Take the high value, the low value, average them, and that comes us a more accurate answer to what the actual area is. Now again, we're going to eventually get to fundamental theorem of calculus, which we'll be able to solve for the actual area. Alright, but since we can't solve the limits, we do this left-hand Riemann sum process. So I'm going to do an application of each type. I'm going to do an application of a geometric type, like the first one, and then an application of the Riemann sum type. Right, which again, I believe I'm just going to do the left-hand side. Right, so I'm going to do that in the next videos.